let's go through these questions. For grade 10 trigonometry, calculate the value of the following expressions. Show all calculations. Answers are to be left in said form if necessary. The first question, these are special angles, so we don't use a calculator for these ones. So tan 30 there from our triangle. This is our 30. Tan is opposite over adjacent. This is 1 over root 3 multiplied by cos 30 there. This is your 30. Cos is adjacent over hypotenuse. So that is root 3 over 2 there. And this is plus sin 30. Sin 30 is opposite over hypotenuse. That is 1 over 2 there. And then simplify. We have root 3 cancels with root 3. We are left with 1 over 2. So this is 1 over 2 plus 1 over 2. That is equal to 1. And then for the second one, we have special angles once again. Sin 60. This is your sin 60 is opposite over hypotenuse. That is root 3 over 2 multiplied by cos 30 there. This is your cos 30 is adjacent over hypotenuse. That's root 3 again. Root 3 over 2. And this is all divided by sec 60. Sec 60, let me write it here. Sec 60 is the same as 1 over cos 60 there, right? And we said cos 60 is 1 over 2. Cos 60 is 1 over 2. That is adjacent over hypotenuse. But when you turn it upside down like this, it's no longer going to be saying 1 over 2 or adjacent over hypotenuse. So your sec 60, the reciprocal for cos, it is equal to hypotenuse over adjacent. And this is going to be 2 over 1. So here we are saying divide by 2 over 1. And this is going to be equal to root 3 over 2 multiplied by root 3 over 2. Change the division to multiplication. This was 2 over 1. It becomes 1 over 2. Now we can simplify. Root 3 times root 3, it gives us a 3 times 1. So on the numerator we have a 3. 2 times 2 times 2 is an 8. That is the answer for this question. And then question 2.2, this is a reduction formula. This is reduction formula. For most people, you only meet it in grade 11, but here it was introduced to grade 10 learners. That's why it is being examined here. To simplify this one, we need to know the cast diagram. Our cast diagram there, it says all of them, sine, tan, and cos. Sin 360 minus theta, which quadrant is it? It is in this quadrant, and sin is negative in that quadrant. So this one gives us negative sin 30 when you have reduced it, multiplied by cos 180 plus theta, that is quadrant number 3 there, and cos is negative there. So we have negative cos theta. This is all over cos 180 minus theta. This is the third quadrant there, and cos is negative. So this gives us negative cos theta multiplied by sin 180 minus theta. That is the second quadrant once again, but sin is positive there. So this is multiplied by sin theta. Simplifying there, we have sin theta and sin theta, they cancel each other. We are left with a 1, and then a negative cos and a negative cos, they cancel each other once again. So these two negatives, they've cancelled each other. We are left with just this negative. So the answer there is a -1. Let's go to question number 2.3. Question number 2.3. If 5 cos theta minus 3 is equal to 0 and your theta is between 180 and 360, use the sketch of with the use of a sketch and further calculations, answer the questions which follow. So we need to draw the sketch first. Where do we draw the sketch? Let's first rearrange this. Make cos theta the subject of the expression there. Take your 3 to the other side and then divide by 5. So we are saying 5 cos theta is equal to 3. We've taken 3 to the other side and then divide by 5. We have there cos theta is equal to 3 over 5. We have that cos theta is equal to 3 over 5. And then, according to what we have here, our theta is between 180, this is where your 180 is, and 360. So it's likely to be in these two quadrants, right? Which quadrant should we go to? Our theta there, our cos theta is positive. If it is likely to be in one of these two quadrants, then it definitely has to be here because it's saying cos theta is equal to 3 over 5, which is positive. Cos theta is positive in the fourth quadrant. So let's draw our diagram there, and then there we are, and then in the fourth quadrant, and it's 90-degree angle there. This is our hypotenuse. Cos theta is equal to 3 over 5. That 3 over 5 is adjacent over hypotenuse. So our adjacent there is a 3. Our hypotenuse there is a 5. The moment you have these two, you need to calculate the third side using Pythagoras theorem. And this one is a 4, but the 4 is on the negative side. So this is -4. Here is our angle theta there. So this is the diagram that you are supposed to use. Make sure you draw it in the correct quadrant. Now, determine the value of 1 minus sin theta. This sin theta, we need to get it from the diagram. Your sin is adjacent over, your sin is opposite over hypotenuse. So your sin theta from here, this is going to be 1 minus sin theta there is opposite over hypotenuse, that is -4 over 5. The double negatives there, this is going to be then 1 plus 4 over 5. This is going to be equal to 1 is the same as 5 over 5. Ne? So on the numerator is 5 plus 4, that is your 9 over 5. That is the answer there. And then prove the fact that tan theta is equal to sin theta over cos theta. How do we prove this? We make use of a diagram there. We can actually make use of this from our diagram. The left hand side, when you are proving, you deal with the two sides separately. So let me start with the left hand side. My left hand side is saying tan theta. From my diagram here, what is the tan theta? Tan theta is opposite over adjacent. Opposite over adjacent. So the tan theta here is -4 over 3. And then now, the right hand side. Let's deal with the right hand side. We are making use of the diagram that we have. The right hand side has on top sin theta. Your sin theta there is opposite over hypotenuse. That is -4 over 5. And this is divided by cos theta. Your cos theta, we have it here. Cos theta is 3 over 5. So this is over 3 over 5. Let's rewrite it as negative 4 over 5 divided by 3 over 5. Change this division to multiplication. Negative 4 over 5 multiplied by, when you change this to multiplication, it becomes 5 over, this is 5 over 3. There we are. And then the 5 and the 5 will cancel each other. We are left with a 1. Negative 4 times 1, we have a negative 4 over, this one is equal to 3. And this is equal to the left hand side. So tan theta is equal to negative 3 over 5. And then sin theta over cos theta is also equal to negative 4 over 3. These two things are equal, so we have proved that tan theta is equal to sin theta over cos theta. And then question number 3, we are almost there. Question number 3, this is a function, a few marks on the function of sin theta. The sketch below shows the graph of y is equal to a sin theta. This a here is your amplitude. It has two functions. It tells you how high and how low the graph is going. It also tells you whether it's a positive one or it's a negative one. It's like that with all the functions. All right. Now, what is the value of a from here? A is our amplitude. That is the highest point. There is a positive 2, is a negative 2. So your a here is equal to a 2. So the function actually has to be y is equal to 2 sin x. The 2 is positive, so it starts with going up. If the 2 was negative, it was going to start with going down, up, and down. All right. That is the first question, the value of a, and then the period of the graph. It completes one revolution after how many degrees? Look at this. This is a half circle. This is a half circle. If we take those two circles, put them together at 360, they are making a complete revolution. So your period here is 360 degrees. You should know that the graph of sin theta and the graph of cos theta, both of them, the period is 360. They are different from the one for tan. Y is equal to tan theta. The period for tan is 180 degrees. And then the range is talking about the distance between the maximum height and the minimum height. That is our range. So our range here, this is an element of starting from negative 2 going to positive 2. That is our range here. Or we could write it as negative 2 is less or equal to y, less or equal to positive 2. That is our range. And that's all I have.